right, this is APAB, and we are back with example 2 in 2.1. All right, so we're given that f of x is the square root of x, and the first thing we're asked to do is find f prime of x. And again, I'm gonna add that little caveat that you have to use the limit process. I promise that when we get to 2.2, you're not gonna have to use the limit process, and you're gonna have much faster ways to find a derivative. But right now, we're differentiating the old school, long, painful way. Sorry. Okay, so we're going to find f prime of x. We're then going to evaluate f prime of 1, f prime of 1/4, and then talk about what happens when you try to evaluate f prime of 0. And that's going to lead us into an interesting conversation a little bit later in this section when we talk about differentiability and what that means. Okay, so let's go ahead and walk through this. I'm going to go back to using h because I think the h's are easier than the delta x's. So first thing I'm asked to do is find f prime of x. So let's do the limit as h approaches 0 of f of x plus h. Well, that's going to be an x plus h anywhere there was an x in the original function, minus f of x, which is just the square root of x, all over an h. Ignore my capitalizing some h's and not others. I clearly failed kindergarten. Cool. So you can see right away that I can't plug in, just like has been true every other time. I would get 0 over 0. And the problem is that you can't clean this up the way you've cleaned up a lot of other things. In order to clean this up, you're going to have to rationalize. Right, we've seen that when we simplified other limits algebraically, right? This is my a minus b. I need to create an a plus b to do the difference of squares, right? So I'm going to create a square root of x plus h plus a root x on both the top and the bottom. Again, ignore my random capitalization of things. Obviously, I failed basic school. Okay, so I'm going to FOIL the root floor, just like we saw when we did, I believe it was section 1.3. So when I FOIL the root floor, I'm going to get root x plus h times root x plus h, which is going to give me an x plus h. The outer and inner will sum to 0. That's the point of a difference of squares, is that the the outer and inner, sums to 0, because this product is the same as this product, but they have different signs. So they're gone, and then my back seat would just be a square root of x quantity squared, which is an x. On the bottom, I'm going to get an h times this ugly root thing that I'm not going to clean up, right? Because I want that h to cancel, right? So I FOILed the root floor. Right, so I FOIL, and again, root floor is not a math term, it's just the way I described the floor that had the roots, right? And then I don't FOIL the other floor. So what happens on the top is I'm pretty sure that I get an x minus an x, and I'm just left with an h. So the limit as h approaches 0 of an h on top of h times this whole ugly mess. Well, that h on the bottom is factored out, so I can cancel it and just put a 1 on the top. So when I plug in, I get that my f prime of x is a 1 over root x plus 0 plus root x. So I get 1 over 2 root x. So that's my answer to part 1, is 1 over 2 root x. Okay. Now, evaluating is pretty simple if you found that derivative, right? Once you have differentiated, you're just going to plug in the value I asked for. So when I asked for a 1, so in part 2 when I said what is f prime of 1, that's just going to be 1 over 2 root 1, which is a 1/2. In part 3, when I ask you for evaluating at 1/4, f prime of 1/4 is going to be a 1 over 2 root 1/4, right? Which is a 1 over 2 times a half, so I think I just get a slope of 1, right? And now, the last thing I asked is what happens when you try to evaluate f prime of 0. So let's look at number 4 here for a sec, and then we're going to take a visual look at the square root of x graph and see what's happening and why. So f prime of 0 would be a 1 over 2 root 0, but that's not okay, right? You're not allowed to divide by 0, so you can't divide by 0, okay? So that's not the answer. The answer is at x equals 0, f of x is not differentiable. And that's what we're going to talk about in the last videos once we get through the next couple things. So it's not differentiable, right? You cannot take the derivative. So you can't find f prime of 0. It doesn't exist. F is not differentiable at 0. So let's take a quick look visually at what a graph looks like and see why that might be the case. So we haven't yet talked about differentiability, but this will lead us nicely into the thing that we will talk about in a video or two, okay? This is what the square root of x looks like. Okay, it's a terrible version of the graph, but you get the gist. So we already saw that the slope at 1 was a slope of 1/2, right? And that the slope at 1/4 was a slope of 1, right? The issue here, and I'll try and pick a different color for this one, is that this guy right here has a vertical tangent slope. There is a vertical tangent line, shouldn't say slope, vertical tangent line rather, at x equals 0. So when we talk about what makes something not differentiable, we're going to talk about a handful of things, and one of them is a vertical tangent line. So a vertical tangent line is one of a handful, rather than give you a number, I'll say a handful, of visual cues that a function is not differentiable. Like, you cannot take the derivative at a given point, okay? And that's going to be the last thing we talk about when we get through some other stuff today, but that's why you're not able to find that value. You end up with 0 on the bottom algebraically, but when we talk about a list of visual things where we're not able to differentiate, that's one of them, okay? All right, I'm going to give you a P2 that is similar. All right, so for P2, I won't make you do all the other steps, but I want you to give you that f of x is, let's do the square root of, let's do x minus 3, all right? And what I want you to do is I want you to find f prime of x, again, using the limit process. No cheating. And evaluate f prime of, let's do 7, and f prime of, let's do 12. Sure. Okay. So pause me if you want. I'm going to go ahead and walk through that skill set, and then we'll go from there, okay? So I'm going to use h again because, again, I'm just totally lazy and don't feel like dealing with the, so my f of x plus h is going to be x plus h minus 3, because anywhere there was an x, I now replace it with the quantity x plus h, minus the square root of x minus 3, right, all over an h. So I'm going to create that difference of squares, right? I have an a minus b, and I'm going to multiply by a plus b, right? So this is my a minus b. I'm going to multiply by a plus b. So I'm going to multiply by the square root of x plus h plus 3 plus the square root of x, minus 3. This is where you got to be careful because you do silly things like that. Plus the square root of x minus 3. And then the same thing on the bottom, x plus h minus 3 plus the square root of x minus 3. All right? And I'm going to FOIL the root floor, just like we've seen. So I'm going to FOIL the floor that is a difference of squares, whether it's the top or the bottom. In this case, it's the top, right? So I'm going to get, this is the limit as h approaches 0. Remember, when I FOIL this, I'm going to get this whole quantity squared. So I'm going to get an x plus h minus 3, right? Because that's my first. My outer and inner are going to sum to 0, right? Because the outer and inner are going to be the same product. This root times this root, same two roots, but one is positive, one's negative. Minus, the last is just going to be the quantity x minus 3, right? Notice that it should go in parentheses because it is that entire quantity that is being subtracted. When I now clean this up, what's going to happen... All right, so anywho, so when I distribute this negative to the entire binomial, I get that this is the limit. Oh, sorry, hey, come on, brain. I was in the middle of stuff, I got an interruption, and then my brain completely died. So a really common mistake is to forget, as I almost just did, that this whole thing was still on the bottom, right? So when I clean this up, I get x plus h minus 3 minus x plus 3. So x plus h minus 3 minus x plus 3. See how the things that don't have h's magically sum to 0 and will go away. So I'm going to get this h times the square root of x plus h minus 3 plus the square root of x minus 3. So these guys all sum to 0, leaving me with just an h on the top that I can cancel with the h on the bottom. So I'm going to get the limit as h approaches 0 of a 1 on top of root x plus h minus 3 plus root x minus 3. When I plug in, I'm going to get that my f prime of x, since h is the only 0 I'm plugging in, is 2 of this root x minus 3 on the bottom, right? A 1 on top of 2 root x minus 3. So that's my f prime of x, right? And then I'm asked to evaluate, second thing I asked to do is to evaluate at both 7 and 12. So f prime of 7 is going to be a 1 over 2 root 7 minus 3, which would be root 4. So I'm going to get 1 over 2 times 2, so 1/4, right? And my f prime of 12 will be 1 over 2 root 12 minus 3, which is 9. So that's going to be a 1 over 2 times 3, which is a 1/6, okay? So 1/6. Cool? All right, so that's our P2. Now, teachers can definitely make this a more arduous process by giving you something like an x cubed, right? Because if you had an x cubed, you can imagine that foiling out or distributing an x cubed would be a lot more tedious than dealing with, say, an x squared. And that's where Pascal's triangle kind of comes into play. So we're not gonna do multiple examples on this. I just want to walk you through what would happen if I gave you something that was cubic. I'm also gonna erase these formulae at the bottom at this point because I feel like hopefully after using them a few times we should feel pretty comfortable with them. It's also totally okay as you're working through problems to flip through your book or your notes to do it. You just want to make sure that as you get close to exams, you have the material memorized that you need. So I'm going to go ahead and give you an example 3. I won't do a P3, but I just want to do, so higher order, higher power tells you to use Pascal's triangle. And you don't have to use Pascal's triangle, but it's helpful, right? So let's say I gave you an f of x equals, let's do x cubed plus 5x squared minus 7, okay? And I ask you to find f prime of x, okay? So what's frustrating here is that foiling out x plus h quantity cubed is going to be a little bit tedious. So the first thing I want to do is set my derivative up. So my f prime would be the limit, and I'm going to use h again because I'm feeling lazy. Limit is h approaches 0. My f of x plus h, well, that's going to be each one of these x's replaced with an x plus h. So x plus h quantity cubed plus a 5, x plus h quantity squared minus a 7, minus, in parentheses, whatever f of x was, right? So I just copy my f of x all over an h. So when you do a problem like this, I'm going to suggest that off to the side somewhere you just do the work on this in case you need it, okay? So let's talk about this x plus h quantity cubed, right? So I briefly mentioned Pascal's triangle in a couple videos back, right? So Pascal's triangle looks like this. Starts with a 1 in what we're going to call row 0, and then 2 1s in what we call row 1. And then basically, to get the next row, you start with 1s and you sum the 2 numbers above it. So 1, and then the 2 is the sum of the 2 1s, and then end with a 1. Next row would be a 1, 3, because that's the sum of the 1 and the 2, another 3, because that's the sum of the 2 and the 1, and then end with a 1. And if you kept going, you'd have a 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1, etc., right? So the trick is that if you use the row that has the same number essentially as the power you're looking at, you can find the coefficients of your terms. So if I want something cubed, I'm going to use the row 1, 3, 3, 1. So x plus h quantity cubed, and again, this isn't technically a calc lesson, this is just a quick useful skill lesson from what you probably learned in either Algebra 2 or Pre-Calc, depending on your teacher. Basically what happens is I use these coefficients, 1 plus 3 with some stuff after it, plus 3 with some stuff after it, plus a 1 with some stuff after it. And then I start with this first term at its highest power, which in this case would be the 3, and I work my way down till I get none of that first term at all, right? And then I do the same thing with the backseat term, right? But I work from the back with the highest possible power and work my way down until there's no term at the front. And so this is how you'd FOIL out this entire mess. Now your other option is to write it as this, and like FOIL these two out and get an answer and then distribute, and you'll get the same spot, but it takes a lot more time, right? The same thing's true with this 1, 2, 1, although hopefully you're a little bit more comfortable with the quantity squared. So I just want to just throw this out there so that you were familiar with it. So when I clean up this whole expression at the top then, right, I'm going to get this whole thing, so I'm just going to kind of segregate this so that it's clear that this was work, right? And this is not the actual equal to. So I'm not saying this stuff is equal to this whole expression because that would be wrong. I separated this chunk of the work so that this piece of the work is clearly just separate scrap work, right? So I get the limit as h approaches 0, right? And then what I'm going to do is in purple, I'm going to go ahead and write this thing out, right? So I get x cubed plus 3x squared h plus 3x h squared plus h cubed, right? This guy is going to be the thing I've already done a couple times in 2 other problems, but with a 5 in front of it. It's going to be a 5 in front of that x squared plus 2xh plus h squared, right? So when I distribute the 5, I'm going to get a 5x squared plus 10xh plus 5h squared. And then I have a minus 7, right? That's this guy, minus 7. And then at the end of all that mess, and again, this is why I've mentioned that you're probably going to turn your paper to landscape, you're going to need to squeeze this stuff in too, right? So you're going to get a minus x cubed plus, minus 5x squared. So I'm distributing that negative, right? And then a plus 7, okay? All over h. And again, I kind of had to squeeze that in at the end. I'll inch over so you can see it. It's kind of squeezed in. All right, so now remember, anybody that doesn't have an h is magically going to sum to 0. So this negative x cubed is going to match with this x cubed. This negative 5x squared is going to match with this positive 5x squared, and this positive 7 is going to match with that negative 7, right? So now, what's going to happen is everything that's left is going to have a GCF of h. So I'm going to get that this is the limit as h approaches 0 of, I can yank that h out. So I'm going to yank one h out of all of these that were left, right? And I'm going to get 3x squared plus 3xh plus h squared plus 10x plus 5h, right? I took one h out of all of them, right? All on top of this h, which means these guys can cancel. So now when I plug in, any term that has an h is magically going to disappear. So my f prime of x is going to be 3x squared plus, that's got an h still, so 0 plus, that's got an h, 0 plus 10x plus 0. So my final answer is a 3x squared plus 10x. Now, as soon as we get to the next section, you're going to be able to do that in your head. Like, I can look at this and tell you this answer very quickly in my head, and that's not because I'm really good at math, it's because I know some stuff you don't know, and you're going to know that stuff soon too. So, anyway, all right, cool. We're going to wrap this video here, and then our very last video of this section, we're going to address both of these things, an alternate form of the derivative, given it some x equals c, and then we're going to talk about differentiability, what its definition is, and what it means visually. Okay?